Active current mirrors, as mentioned earlier and exemplified by the circuit of figure, current mirrors can also process signals, that is, operate as active elements. Particularly useful is a type of mirror topology used in conjunction with differential pairs. In this session, we study this circuit and its properties. First, let us examine the circuit shown in figure, where M1 and M2 are identical, neglecting channel length modulation. We have I out is equal to I in, that is, with the direction shown for I in and I out. The circuit performs no inversion from the small signal point of view. If I in increases by delta I, so does I out. Now consider the differential amplifier of figure A, where a current source in a mirror arrangement serves as the load and the output is single-ended. What is the small signal gain? AV is equals to V out by V in of the circuit. We calculate AV using two different approaches, assuming gamma for 0 for simplicity. Note that owing to the lack of symmetry, the half circuit concept cannot be applied here. Here you can see the figures: A differential pair with current source, load; B circuit for calculation of GM; C circuit for calculation of R out. Writing mod AV is equals to GM R out and recognizing from figure B that GM is equals to I out by V in is equals to GM1 V in by 2 by V in is equals to GM1 by 2. We simply need to compute R out as illustrated in figure C. For this calculation, M2 is degenerated by the source output impedance 1 by GM1 of M1, thereby exhibiting an output impedance equal to 1 plus GM2 R02 into 1 by GM1 2 plus R02 is equals to 2R02 plus 1 by GM1, similar to 2R02, thus R out similar to 2R02 similar to R04, and mod AV similar to GM1 by 2 into 2R2 parallel R04. Interestingly, if R04 tends to infinity, then AV tends to GM1 R02. This can be explained by the second approach. Here you can see the figure circuit for calculation of VP by Vn. In our second approach, we calculate VP by Vn and V out by Vp and multiply the results to obtain V out by Vin with the aid of figure. Vp by Vn is equals to R equivalent by R equivalent plus 1 by GM1, where R equivalent denotes the resistance seen looking into the source of M2. Since the drain of M2 is terminated by a relatively large resistance R04, the value of R equivalent must be obtained from from equation. R equivalent is similar to 1 by GM2 plus R04 by GM2 R02 is equals to 1 by GM2 into 1 plus R04 by R02. It follows that Vp by Vn equal to 1 plus R04 by R02 by 2 plus R04 by R02. Note that if R04 tends to 0, Vp by Vn it tends to 1 by 2, and if R0 4 tends to infinity, then Vp by Vn tends to 1. Now we calculate v out by Vp while taking R0 2 into account from figure. V out by Vp is equals to 1 by 1 plus Gm2 R0 2 by 1 plus R0 2 by R0 4. Here you can see the figure, a circuit for calculation of V out by Vp, similar to Gm2 R0 2 by 1 plus R0 2 by R0 4. From equation we have V out by Vin. V out by Vin is equals to 1 plus R0 4 by R0 2 by 2 plus R0 4 by R0 2 into Gm2 R0 2 by 1 plus R0 2 by R0 4 is equals to Gm2 R0 2 R0 4 by 2 R0 2 plus R0 4 is equals to Gm2 by 2 into 2 R0 2 parallel to R0 4. In the circuit of figure, the small signal drain current of M1 is wasted as conceptually shown in figure A. It is desirable to utilize this current with proper polarity at the output. This can be accomplished as depicted in figure B, where M3 and M4 are identical. To see how M3 enhances the gain, suppose the gate voltage of M1 increases by a small amount, increasing ID1 by delta I and decreasing ID2 by delta I, since mod ID3 and hence mod ID4 also increase by delta I. We observe that the output voltage tends to increase through two mechanisms. The drain current of M2 drops and the drain current of M4 rises. In contrast to the circuit of figure, here M4 assists M2 with a voltage change at the output. This configuration is called differential pair with active current mirror. An important property of this circuit is that it converts a differential input to a single-ended output. The reader may wonder how it is possible if KCL requires that ID2 is equals to mod ID4. The explanation in example clarifies this issue. It can also called a differential pair with active load. Here you can see the figure, a concept of combining the drain currents of M1 and M2 be realization of A. Thank you.